Here. Is the whiteboard visible? Okay. So, anybody who will give the answer for false positives and false negatives? What are these? Where are these used? Among Chandra Prakash, you don't answer any of my questions. Are you even there in the class or just like
Yes, ma'am, actually studying. I am network issue, so I am not attending the class. So while going through down this now.
what should I say? I don't know. Okay, I'll only answer this. Now, what happens is whenever you are trying to log on into a particular system, okay, uh, how do you do it? You provide your login ID, and
Ma'am, your voice is not clear.
am I audible now?
I'm so much of interference. Um,
I'll disconnect it and then log in. Okay. Am I audible now?
yes, ma'am.
Okay. So, what was I saying? To log on into a system, you'll give your login ID and you'll give your password. If your credentials are present at this system's end and are matched according to those credentials which are stored, then the user would be provided the access. Okay. Had it not stored those credentials, it would prompt the user that incorrect password is there, or probably there is an intruder who is trying to log on into the system, and therefore if he has a better defense, or if the system has a better defense mechanism, your system would not allow the intruder to intrude into the system. So that should happen into any traditional system which has security credentials required for logging in. Okay. Now, there are some cases where any user who is an authenticated user, when would a user be a proper authentic user? When his login ID and passwords correctly match, this combination correctly match, and it is stored into the system. And that means that the user is correctly identified and then it is authenticated. Okay. Now, there are multiple cases where if there is an error onto the system which says that the uh, provided credentials do not match with the stored one, even if the user is actually the correct user. So what does this mean? This means that if the user is legitimate, the user can't be intruded. This is the traditional thing. If the user is legitimate, the user can't be intruder and he needs to be given access. Okay. But sometimes this doesn't happen. What happens instead? That the user is giving his credentials even though he is a legitimate user, but the system is prompting that the user is an intruder. Okay. So what is the system prompting? System is prompting that there is an attack being happening into the system, or the system is not allowing the legitimate user to access what he is allowed to access. Okay, so what is this? This is an event signaling to produce an alarm when no attack is actually happening or when no attack is taking place. Such case is referred as false positive. Okay, so what does this mean? You are categorizing a legitimate user as an intruder. Clear? Any doubt?
Amen.
Fine. Next thing we need to discuss what is false negative. Okay, false negative occurs when no alarm is raised when an attack has taken place. In layman terms, what it means that an intruder is trying to gain access into the system. The system was server gave access to the user. Clear? Now, again, I'll repeat, when a non-legitimate user is given access into the system, when a non-legitimate user is given access into the system, such case is referred as a false negative case. Okay? In case of a false positive case, your legitimate users are not given access. In a false negative case, non-legitimate user is given access. Clear? Now do not confuse false positive with the case that what would happen to the non-legitimate user. False positive में legitimate user को access नहीं मिलती. Clear? Now, when a legitimate user is not given access in a false positive case, this doesn't mean that every legitimate user is not given access. Okay, so let's say there are 100 users who are enrolled into the system. Among these 100 users, the system raises concerns for 95, the system raises concerns for 95 users. What concerns? He tells that among these 100, 5 users are not given access. Okay, it is saying that these 5 users are categorized as intruders. Clear? This is the case of false positive. So if there is any user who is a 101th user, technically he should be a non-legitimate user. Okay, but in case of false positive, we are not talking about non-legitimate user. We are not concerned about non-legitimate users. Here, 101th user would obviously be discarded, but the discarding is done for these 5 users as well, which are part of this 100. Okay, so if I want to say a few line about false positive, I'll always say that in case of false positive, the legitimate users are denied access to a resource. Okay. In case of false negatives, the non-legitimate users are given access. It is not talking anything about legitimate user. It is only discussing facts about non-legitimate users. Clear? Any
Yes,
doubt?
ma'am.
Okay. So I'll say that in false positive, we investigate many brute force alerts, find out that it was just some user who possibly mistyped the password, which is possibly a case which happens in a real attack, but it did not happen. Okay, that is why it gave you a false positive. False negative means that there actually was someone who's trying to break into the system who is technically a non-legitimate user, but they did so below the threshold of your brute force attack. So you were trying to log in into the system. Let's say you have a rule that for 10 failed login into the system, you will block the user. But your attacker did only for 9 times. So the attack occurred in those 9 times itself. So here your rule failed. Okay. So you are giving access to your non-legitimate user in this case. That is why it is classified as a false negatives. Okay. So along with these, you have true positives and true negatives. Okay. What happens in true positive? In true positive, a legitimate attack which triggers to produce an alarm. Okay. When a brute force attack alert is generated, it is triggered and you investigate it. Find out that somebody was trailing via any attack mechanism. What happens in true negative? Any event when no attack has taken place and no detection is made. So कोई अटैक भी नहीं हुआ और तुमने कोई रूल भी नहीं बनाया. Clear? Study these concept of true positive, true negative, false positives, and false negatives. It's a very important concept which is used in security. So every time there would not be explanation that authorized users are given access or not. You'll be using the terms like false positives होंगे या false negatives होंगे या false true positive होंगे या true negatives होंगे. Okay. Now considering this false positives and false negatives aspects, there is one theory that whenever we are trying to have a system and you are categorizing how many number of false positives will be there, how many number of false negatives will be there, we'll use only these two. Okay, so for false positives, what is there? You are having legitimate users denied the access, negative non-legitimate users given access. Okay, so if you're developing any system, you would want very less legitimate users to be denied access. Clear? So you want less false positive rate. Clear? Non-legitimate users given access, which happens in false negatives. Should this be increased or should this be decreased?
Decreased.
This should also be decreased. Clear? But when we are talking about this aspect in a system, so if I am trying to develop and to decrease the number of false positives, when I have a defense, possibly there can be a case that your false negatives are increased. Okay, if I am trying to increase this, possibly this can decrease. So this would be decreased if I increase it. So what I'm trying to say is that when you are developing a system, you need to develop that system in which both of these should be given a trade-off. You cannot make the value of false positive rate 0, neither you can make the false negative rate 0. But you can come to a state which is a compensatory state where there would be fewer set of users who are legitimate users who are denied access and fewer set of non-legitimate users who are given access. You will not have any system which is a foolproof system. Okay, so our goal should be lesser false positives as well as lesser false negatives. Okay. Now, considering this aspect, if I come back to what we were discussing in last class, we were discussing the source-based defense. So we had discussed one of which it is ingress or egress filtering. Today we'll be discussing the other one which is referred as the word. Now, when we are talking about the word, so this defense mechanism is a source-based defense mechanism, and this majorly aims to detect the DDoS flooding attacks. Okay, okay. How is it trying to detect or prevent the flooding attack? This is doing by monitoring both the inbound and the outbound traffic. So this is your network. By monitoring both the outbound and the inbound traffic of a source network and pairing the network traffic information with the predefined flow, your D word is based. So I'll make it understandable in a very layman terms. What it is D word trying to make is D word is attempting to stop the attack traffic from the originating network or traffic which is originating from a network at the border of the source network. So this is your source network. What would D word try? Your D word would be employed at the boundary of this particular source network, and it would try to drop the packets by limiting the rate of inflow and outflow of the packets from the network. Okay. Now what would be done? Your attack flows would be identified and filtered if they mismatch the normal flow. How do you categorize that it is not a normal flow or which is normal flow? For instance, if I say that you have a TCP packet. So in case of a TCP protocol, every packet will be acknowledged by the receiver. Clear? So you have the flow of packets in this form. So there are two connections which are sent from the client, and one packet which is sent is there from the server. Okay, so you already know what is the ratio of the packets which are sent. So here what is done is that the normal traffic model for TCP would be considered by maximum allowing ratio of the number of packets sent and received in the aggregate TCP flow. Now, a normal model for all other traffic types could be done for in this similar way only. Now, the D word can generate specific filtering rules at the source. Okay, so what would it say that for TCP I am requiring a ratio of 1 is to 2 connections. Okay, in this 1 is to 2 connections, let's say the rate of the flow of packets is at 10 packets per second, and this has around 30 packets per second. Okay, so these are certain standard flows which should be maintained by the incoming and the outgoing packets. So this information is stored somewhere into the server when the and it is categorized as the normal flow. So when the incoming and the outgoing packet or when the incoming and outgoing traffic is observed and it is found that the ratio of the connections is also not appropriate, neither is the data flow in both of these connections is according to the information which is stored at the server side. In that case, what would happen? Your D word would be activated, or it is already activated and it is monitoring all of the inflow and outflow. If any violation in the traffic flow is identified, your reward would start dropping the packets. Okay, so here the dword can generate filtering rules at the source. Okay, now when these rules are generated at the source, what would happen? It would consume more memory space, it would consume CPU cycles, okay, which is actually majorly part of your network-based defense mechanism. So even if you're employing dword and you are able to filter the packets, but this would not provide you very much intense incentives in case of storage. Okay, you would employ extra devices at the server side or at the client side to store the rules, to store what is the normal packet. So it is not just the case that only TCP packets will flow. There would be multiple packets which are flowing into the network. So for every packet, you'll have to store the information about what is the normal flow. Okay, so normally when you're storing the information, you'll require extra memory space, which can also be considered as that it is having DDoS. It might lead to a DDoS attack, or it might lead to any denial of service attack at the server site itself. Okay, so here what would be done is you have a case where you are preventing DDoS. You're preventing DDoS by deploying dword, but dword deployment may further degrade the performance of the network, which might lead to denial of service due to adding of the defense as well. Okay, so initial may there would not be any problem with the system, but however at a later state when the traffic is higher into the network, in that case it can drop the legitimate users packets as well. Okay, so it can be said that there is might be a situation where your dword can be easily bypassed by the attackers who can actually control the traffic also to be within a normal range. So if I am an attacker and I know that my dword is programmed in this way and it would only accept those traffic which are within these acceptable limits. So I can send in the packets to the source, which would obviously be malicious packets, but those packets can be sent in a minimum range. So I'll send these spurious packets within this 10 packets per second or 30 packets per second. So this would obviously, even if the keyword is deployed at the sources end, it would be able to not identify that this is an attacker's packet. Okay, and the system has already been attacked. So D word is yes a defense which is suitable for DDoS, but is suitable only in this case when your attacker is not aware of certain rules on what basis the filtering is happening. Clear? Any doubt? Any doubt? Can you tell me, will there be cases of false positives and false negatives?
Yes, ma'am.
बताओ कौन सा?
Ma'am, if attacker is following the rules, then it will be in false negative because it will not drop the packet.
false negatives होगा. Okay. Will false negatives be higher or false positives be higher?
Ma'am, false negative.
How are you so sure that false negatives will be higher?
Maybe, maybe not sure.
Your false positives can also be higher. Reason is that every legitimate user is not aware of the filtering mechanism which keyword has. So if there is a legitimate user who is sending the package to the server, and the rate of inflow of the server is lesser than the rate of outflow of the client. Understood? So your client can send in the packets at a higher rate than your server can process. So this can be a system. Okay. So based on this, your D word can drop the packets of the legitimate users, which might lead to false positives. Understood the case?
Ma'am, can you please repeat it?
Okay. So uh, we have client and servers present. This doesn't mean that both of these are present on same network. Okay. Every client or every system which is present onto the network has different network bandwidth available and different TCP window, different what should I say, processing and throughput latency, all of these. So there can be a case where when your client is sending the packets to the server, these are at some n rate, okay, and the reception rate of the server is not equivalent to n. It might be higher than n and it might be lower than n. Okay, so if it is lower than n, this means that rate of outflow of the packets from the client is higher than the rate of inflow of the packets at the server side. So you have client and server. Your client is sending multiple packets. उसने 5 पैकेट सेंड किए, लेकिन सर्वर के पास कैपेबिलिटी है सिर्फ एक बार में वो 3 पैकेट्स को रिसीव कर सकता है. ठीक है, तो जो डी वर्ड होगा वो या तो क्लाइंट के बेसिस पर बनेगा, रूट्स की प्रोसेसिंग स्पीड के बेसिस पे बनेगा, या फिर सर्वर की प्रोसेसिंग स्पीड के बेसिस पर बनेगा. दोनों की स्पीड के बेसिस पे नहीं बनेगा, क्योंकि हम अज्यूम करके चल रहे हैं दैट योर क्लाइंट कैन बी एन इंट्रूडर. Okay, so if your client is sending the data, that is the outflow of the packets from the client is at a very higher rate than the processing rate of the server. In that case, there would be multiple packets of the client which are dropped by the D word. Possibly those packets are those which contain the legitimate users login ID credentials, which are dropped, thereby increasing the false positive rates, which is you are not allowing a legitimate user to gain access into the server side. Clear?
Yes, ma'am.
Anybody else has doubt? Tanvi, can you explain me how your false negatives will be higher? Why is everybody leaving the class? Am I not audible clearly?
Ma'am, you are audible.
Okay. Anybody else who'd like to answer this question? How would false negatives be higher?
Ma'am, if attacker knows the rules, if he follows the rules, then it will server will accept the packets. Then it will be higher.
If the attacker knows the processing capability of D word, he can limit his packets within the acceptable range and then send it to the server, which obviously might increase the false negative rates. Okay. Um, Now you have only 15 minutes. Now what I'll do, instead of going to any other defense mechanism, let's find out what happens when a legitimate user is denied access to the server. That is, what should possibly be the outcome of having a DDoS attack or a DOS attack. So everybody would have found out that whenever you are sending a ping request, okay, so let's say I'm pinging this client. If this client is present into my network or is present anywhere in the network and is up, you will obviously get a response. Okay. If this client is not up, what response is generated? What response is generated when a ping is not successful?
Ma'am, there will be a connection error.
नहीं, कनेक्शन एरर नहीं आता कभी. करके देखो, राइट? CMD. सुपर आज की क्लास चल रही है मेरी. हाँ, वो है नहीं शायद. हाँ, कुछ है क्या? आप मुझे दे दीजिए, क्या है? अच्छा, कॉन्फिडेंशियल. ठीक है, वो तो आप फिर उन्हीं को फोन कर लीजिए. मैं समझ रहा था आपने स्पीच देना बंद कर दिया. नहीं नहीं, मेरी क्लास चल रही है. हाँ. Got the answer? What is it? What is being sent in ping? You are sending ICMP packets. Here, when you're sending ICMP packets to a particular destination and the destination is not present, what reply is generated?
Ma'am, it's showing lost equal. No, it's showing 100% loss.
100% loss. Okay. Any other error?
Just request timed out, sent equals to 4 and received is 0.
Request
So it's
timeout.
100%
This
loss.
is this is important. It is showing request timeout. Fine. Now this request timeout is equivalent to something which is referred as ICMP, destination unreachable. Clear? So request timeout is ICMP, destination unreachable. Okay. So the destination unreachable message indicates that a frame was discarded because it could not reach its ultimate destination. Clear? Now, we need to find out whether this ICMP destination unreachable is always because the destination was actually unreachable or due to some other reason. Uh, Okay, so one thing is that we need to find out whether the destination was actually present into the system or not, or the next thing what needs to be found out that who had sent this request timeout message. There will be some or the other system who is present onto the network who has replied it. System, हमने अपने आप ये मैसेज नहीं जनरेट किया होगा. Okay, what all clients are there, what all systems are there into the network? You have routers. You have routers. These routers can be edge routers or end routers. Okay, you can have autonomous servers which are there into the system. So there are multiple devices which are present into the system which are involved in sending and forwarding the packets. Clear? So when any ping request is generated and that ping request is not successful, or should I say that when any packet which is sent into the network is not delivered to the correct location and a response is generated for it, this would tell you whether the system is either up or down. So if I want to map this with the denial of service attacks, what can I say is that when a client sends in the request to the server, if the server has crashed or if the client is not allowed to gain access to the server, some or the other message will be received at the client end, which tells the client what has actually happened. Okay, so if there is any flooding attack happening into the system and a client is sending the message to the server, if the message is not delivered to the server or if some error has occurred which is possibly due to DOS, then at the client's interface there would be a message generated which is ICMP destination unreachable. But the reason of generation of this ICMP destination unreachable message can be multiple. It is not just that the server is not up or the system in which I'm sending the message or the network in which I'm sending the message doesn't have the host which you are targeting. Okay, understood? Now, possible reasons why you can have a destination unreachable message is first case that you have network unreachable. I'll only tell you the headings first. Next case can be you have a host unreachable. Third, you can have port unreachability. Fourth, you can have protocol unreachable. Fifth, you can have fragmentation needed and don't fragment bit set. And finally, sixth is source route failed. Clear? So let's talk about the first factor, which is network unreachable. Now, network unreachable might be a reason of getting an ICMP destination unreachable message. Okay, who sends the network unreachable message? Your network unreachable message is sent by the router. Okay. Now, when a router sends a network unreachable message, it is saying that it has no way to reach the network or subnetwork which is specified in the destination IP address. Okay. Now, the destination section of the address is calculated by using the what is used. You have address mask parameter which is configured in the router, which tells you that where in which network you will have to forward this particular packet. Okay. Now, the network unreachable message could be sent by the misconfigured mask value in the router, or it could be due to the non-existence of a particular network. So let's say, what was I sending? I was sending the message ping 1234. Okay. Now, when this message would be forwarded by the router present at this particular network's interface, you would try to find out what is the mask address. When he's forwarding it to a particular router, he would find out that, let's say, 1000. This address is present into the network or not, or there is any network which has this particular address associated to it. If there isn't any network associated to this, then your packet would not be forwarded further into the routers, to the other routers, and the router which is present over here, who had calculated the mask address, would himself reply back to the client saying ICMP destination unreachable. But that destination unreachable is caused due to the factor of network unreachability. Okay, any doubt?
मैम मैम
Yes.
मैम मैम इससे पहले आपने पिंग वाला आपने बताया था मैम, उसमें अगर डॉस अटैक होगा तो मैम ये सोर्स या कोई वो पिंग अटैक भेजेगा या अपने आप ही पिंग अटैक पिंग हमें पता भेजेंगे?
नहीं समझी नहीं मैं, दोबारा बोलो आप क्या कहते, मैंने
मैम
बोला था कि क्लाइंट मतलब अच्छा आप ये क्लाइंट पिंग भेजेगा या फिर अटैकर पिंग भेजेगा
यस
ये बोल
मैम, यस मैम।
सकता है। लेकिन आगे अगर हम डॉस की बात कर रहे हैं अभी, तो हम क्या बोल रहे हैं कि अगर क्लाइंट ने ये मैसेज भेजा, पिंग भेजा, तो क्लाइंट की ऑब्वियसली डॉस अटैक हो रहा है अगर, तो क्लाइंट की रिक्वेस्ट सेटिस्फाई नहीं होगी। सेटिस्फाई अगर नहीं हुई तो क्लाइंट के एंड पे भी तो कोई मैसेज डिस्प्ले होना चाहिए ना। उसके एंड पे मैसेज डिस्प्ले होगा आईसीएमपी डेस्टिनेशन अनरीचेबल। आपके आपने बोला था अभी क्या था, रिक्वेस्ट टाइम आउट। तो क्लाइंट को लगेगा कि ये जो रिक्वेस्ट टाइम आउट हुआ है मेरा, वो क्यों हुआ है, क्योंकि मैंने तो वैलिड सर्वर को रिक्वेस्ट भेजा था जिसको मुझे एक्सेप्ट कर लेना चाहिए था रिक्वेस्ट। ठीक है, बट क्लाइंट के पास रिक्वेस्ट टाइम आउट इसलिए आया क्योंकि सर्वर कोलैप्स हो गया था डॉस अटैक के कारण। ठीक है,
ओके मैम।
कोई और डाउट?
नो
फाइन,
मैम।
we'll go ahead with these topics in, कल क्लास है ना? हाँ, नहीं कल क्लास नहीं है, in Tuesday's class. Okay, I'll send you the documents.